Okay, so once I have my 1/4 width, again, since that's going to be a common width, I'm going to leave that factored out. And you'll see, actually I'm going to use a bracket here, you'll see, again, since we're finding the area or the area of each rectangle, again, area is length times width. So, or in this case, our height times our width. So if you go through, we just need to figure out which heights we need to pull to multiply by that 1/4 width. And again, since we're using the right Riemann sum here, we have to go and say we need f of 1/4. That's the right-hand side of the rectangle here. Notice we don't need f of 0 because that's the left-hand side. And then we could go and do f of 1/2, f of 3/4, and f of 1. Okay, and if you go through, you can see we'll do our 1/4 times the height, and that's the area of the first rectangle. 1/4 times f of 1/2, right? That's going to be the area of the second one, and so on. And you can see that if we take the area of each of our rectangles and add that together, we'll get our final answer. Okay, so with this, we get to use and steal our information from the last problem. So just go back and say, okay, well, I already found all these values. 1/4, and let's just write these in. I'll have 17/16, 5/4, 25/16, and 2, because we found them earlier. And this is where you can decide to go for extra credit or punch them into the calculator. If you want by hand, get a common denominator, add these up, multiply it by 1/4, you will get 47/32. If you get a decimal answer, you would get about 1.469. Okay, and just as a reminder, this would be considered an overestimate, whereas our left approximation was an underestimate. Okay, let's move on now to the midpoint method. Okay, again, we're going to use the same function, that x squared plus 1. So go ahead and get started drawing that. Okay, so once again, here's that parabola. They want us to go from 0 to 1. Okay, we're going to say that's a height of 1. That's a height of 2. Okay, again, now with this one, we don't want to use the width of a fourth because we're going to be using the midpoint of each of our rectangles. So go ahead and draw your rectangles in again. And this time what I want you to do is go in the middle of each rectangle, okay, and draw a dotted line going straight up to your curve. So we're splitting each of our rectangles. And that new height is going to be the height that we need to use in this problem. So I'm going to draw the height here for this rectangle. Same thing, height here, and height here. Last one's hard to see. Okay, so you can see we're going to actually need to compute things. We can't just steal all of our previous work from that last problem because we don't know the height of those midpoint pieces. So the first thing we're going to have to do is figure out the width. So what is between 0 and 1/4? Hopefully you're saying 1/8, so I'm going to write that in there right now. 1/8. Okay? Now, if each half of a rectangle is 1/8 wide, then to figure out the other ones, we can take our piece, like a fourth, and add 1/8 to that. So if this is a fourth, that's really what, 2/8 plus 1/8 gets me 3/8. So the next little orange piece here is sitting at 3/8. Then we have our 1/2 plus 1/8. So again, we're looking at that half, we're adding 1/8 to it. So what does that get me? So that's what, 4/8 plus 1/8, that's 5/8. Okay, so I'll squeeze that in. 5/8 right there. And then finally, we have our 3/4 plus 1/8. So 3/4 plus 1/8, that's 6/8 plus 1/8, that's 7/8. But you can kind of see the pattern there anyway. Okay, so we had to find that because we need to know the height at those measurements. So we now need to find f of 1/8, f of 3/8, f of 5/8, and f of 7/8. Okay, so to do that, we simply take our function that was provided, x squared plus 1, and sub each of these values in. I'll do the first one with you, but then pause the video, do it yourself, and check with me when you're finished. So 1/8 squared, it will be 1/64. We're going to add 1, which would be 64/64, which gets me 65/64. Okay, so that's the work on how to do that. So again, pause the video and finish that yourself, please. Okay, time to check our answers here. So f of 3/8, you should have gotten, hold on, I'm getting my answer here. F of 3/8, I got 73/64. F of 5/8, I have 89/64. And f of 7/8, I got 113/64. Okay, so now we did all of that because we need to go through and estimate using this. So what do I have to do here? Well, I have to again go through and say that I want the area of each of the 4 rectangles that you see. The width of each rectangle is still 1/4 wide. The height is going to be the answer to the pieces that we used. Okay, so again, we had to go through and find the 1/8 and the 3/8 and so on to compute this height. So again, all I have to do to get this final answer, just kind of break this off, is take my width of 1/4 and I have to find the area for each of the heights. So why don't we write f of 1/8 plus f of 3/8, f of 5/8, f of 7/8. Okay, and we're running this board, so there you go. All right, and then we'll just go ahead and fill in our values. So we have our 1/4. Okay, and again, you could use a calculator here, or you could try to do this by hand. In the end, I ended up getting 85/64, which is approximately 1.328. Okay, and that brings us to our last method, which is the trapezoidal. Okay, so for our trapezoid, let's just take a minute and actually review something. First of all, this is a trapezoid, okay, and the area of a trapezoid is, I like to write it like this, base 1 plus base 2 over 2. So that's the average of the bases. If this is base 1 and this is base 2, take the average of the bases and then multiply it by the height, and this would be the height. Okay, so the area of a trapezoid is the average of the bases times the height. So now let's see how that applies to this picture. So again, we're using the same function, x squared plus 1. Okay, and again, they're saying break it up into 4 intervals. So once again, we have that same initial picture. Okay, so let's look at this, and can you kind of see the trapezoid that they're talking about? What we're going to do is picture this trapezoid that I drew turned on its side. And again, it's just easiest to see when I look at this bigger one here. So for the trapezoidal, you're going to connect the two endpoints, and these parallel sides here are your bases, so say base 1, base 2, and that's your height, right? Because your height is drawn at a right angle, the altitude. So this is your height, and these are your bases. Okay, so hopefully you can see the trapezoid that I'm talking about. We're turning this one on its side. Okay, so if you think about this, we have to think about, well, how am I going to go through and get the area of each of these? Well, let's just finish our picture, and I think this is the hardest one to see. Basically, you're just taking the curve out of our parabola, and you can see all of our pieces. So this formula, we'll get to the formula in a minute. Let's just use our heads and think about this. What is going to be the area of our first trapezoid? Well, the height is going to be a fourth, right? So let's do first rectangle, okay? The area of the first rectangle. We're going to have the area of the first rectangle. The height is a fourth, okay, which is right here. And now I need to find the average of my two bases. So base 1 is going to be f of 0, okay? So I'm going to put a bracket, and I'm going to write f of 0. Base 2 will be f of 1/4. And then I have to divide that by 2, right? So base 1 plus base 2 divided by 2. This right here is the area of the first rectangle. I'll go through and do that for each and every one of my rectangles, and then I'll add them together. So when I go through, it's going to look like this. I'm going to, let's see, I'm running out of board space here. I guess I'll write it right below here. So do you see consistently, I'll always have a fourth because each of my trapezoids have a height of a fourth. And I'll also have this 1/2 because the 1/2 comes from the average. So can I actually factor out 1/8 if I factor that out with it? So this area is going to be 1/8 factored out here. And then I'll have f of 0 plus f of 1/4. That's going to be, let's see, we'll do this. That's going to be for the first rectangle. Now the next rectangle, I still would need to do the average of their bases. Do you see I'll have a fourth and a 1/2, right? Base 1, base 2 of the second one. So f of 1/4, f of 1/2. That's the second one. The third one, here's the third one. Base 1 is 1/2, base 2 is 3/4. F of 1/2, f of 3/4. And finally, the last rectangle, base 1, f of 3/4, base 2, f of 1. Okay, so what happens if you look at this here, I have doubles of everything except for the endpoints. So when we look at this formula in a moment, you'll see where all this comes from. And so in the end, all I have to do now is go through and put all of these values in, which again, luckily for us, we already went through and found these values, so this part should be easy. So please right now, flip back. Let's get this answer completed. F of 0 here, you'll just go back and you'll fill in f of 0 is 1 and so on. I'll start to write that in now. Why don't you pause the video and try to compute that yourself, and then in the end we'll see if we have the same answer. Okay, so pause the video, here we go. F of 0 was 1. That's 25/16. Okay, so once I go through and do all of this, I ended up getting 43/32, which is approximately 1.344. Okay, and I did try to show you some work here. Just be careful, order of operations. Go through, add all this together, and then multiply that by 1/8, and you should get what I got here. Okay, so at this point, now that we have gone through and we have tried every type of example as far as the methods, let's go back to that first page in your packet and look at our examples. Okay, so I want to go to page 21 in your packet, please. And I want you to look at the number 2, A, B, C, and number 3. Okay, looking at that, I don't have anything for you to see up here because this is different than what we have electronically. But if you let's look at the trapezoidal while we have this here. Do you see why it says on your paper B minus A over 2n? B minus A, as usual, B minus A over the 2n. The difference from that one and the others is the 2 on the bottom. And the reason why that 2 comes out is because of this 2 right here, guys. Right? We know that that comes from the area of the trapezoid formula. So that 2 is where that affects the formula that I have typed for you. Also in the trapezoidal, you see all the 2's in the second set of parentheses. That comes from this. Notice I have 2 of those values. I have 2 of those values. I have 2 of those values. I do not have 2 values on the ends. Why does that happen? Because as you're finding the average of our bases, doesn't each rectangle share that side? But on the end, this does not get shared by another rectangle. So, or trapezoid, I should say here. Okay, so that's where that all comes from. And then the other ones are pretty self-explanatory. It's just the width times the height. Okay, so some kids like to memorize formulas, and if you do, now they should make sense to you. If you don't feel like memorizing a formula, I think this makes perfect sense. And if you ever get yourself confused, just go through and literally find the area of each rectangle or trapezoid separately, and then start adding them together in the end, and you'll figure it out. Okay? All right, so let's move on to some... Oh, number 9, this is not important at all. You can write down, it says to compare the results here. It turns out that the average of the right and the left approximations end up equaling the trapezoidal, which seems funny because you would think it would equal the midpoint, but it doesn't. So, but I would never ask you a question like that. That's just a, hey, did you know kind of thing. Okay, so don't worry too much about that. Let's go to number, let's see, that would be number 10 for you. And let's check out some notation.